Okay, so for the second part of our discussion, we have the truth table and the quantifier. So, just like what I've said earlier, we're going to utilize all the cases on each connectives that we have discussed, such as for the conditional, biconditional, conjunction, disjunction, and the negation. Okay, but before that, when we construct a truth table, take note that first we need to identify, okay, the number of simple propositions involved. Okay, the number of simple propositions involved in our compound proposition. Now, uh, after that, we're going to identify the number of cases, okay, the possible number of arrangement of all the cases that we need to consider under that proposition. Okay, we have the formula in general 2 raised to n. Okay, we have 2 raised to n. Okay, so take note of this, where n is the number of simple proposition. Okay, so for instance, we have 2 raised to 1, so meaning we have one simple proposition. So we have two cases. It's either true or false. Okay, it's either true or false. Okay, and also when we have two simple propositions such as P and Q, we have four cases. Okay, we have four cases. If you remember, we have that in disjunction, conjunction, biconditional, and conditional propositions. We have four cases, 2 raised to 2. And then we have here 2 raised to 3. So that's 2 times 2 times 2, that is 8 cases. Okay, that's 8 cases. Okay, so we have 8 possible arrangements, cases. Okay, now, for you to easily construct this, remember, when we have 3, we have 3 simple propositions. For the first column, just write 4 true and then 4 false. Okay, so true, 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 false, 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 false. For the second column, write 2 truths, 2 false. Okay, so we have true, true, false, false, true, true, false, false. And then for the third column, we have true, false, true, false. Okay, we're going to write it true, false, true, false, true, false, true, false. Okay, so it's one of the suggested cases. Okay, the arrangement of the cases for you to easily identify the 8 uh, arrangements. Okay, but it depends on you. But again, when it comes to our assessment, we're fixed with this. Okay, we're fixed with this. Okay, so now let's try to consider uh, the descriptions. Okay, the descriptions for the truth tables that we will encounter later. Okay, we call this as the tautology, contradiction, and contingency. Okay, so first off, we have the tautology. Tautology is originated from the Greek words tauto, which means the same, and logos, which means idea or word. Tautology is defined as the repetitive use of phrases or words which have similar meanings. So in our statements, in our compound propositions later, it means that whatever the truth values of each simple propositions, the statement is always true. Okay, the statement or the compound proposition is always true. Okay, so remember at the end of our the last column of our truth table, if all of that is true, we call that as tautology. Okay, we call that as tautology. While if all of the cases, each row in our last column is false, we call that as contradiction. Okay, contradiction in logic is known as the fallacy. Okay, which is in the Latin term falliare, which means to devise. It refers to the errors or mistakes in belief, reasoning process, or an argument that has insufficient evidence for its conclusion. So remember, when it comes to contradiction, all of the rows in our last column is false. Next, we have what if it is neither tautology nor contradiction, meaning it's a combination of true and false. We call that as contingency. Okay, we call that as contingency. Okay, so take note of that. Example of tautology and contradiction. Okay, so here we have the proposition P or negation of P. So as you can see here, we only have one simple proposition P. So therefore, we only have two cases. It's either true or false. Alright, now, in constructing its truth table, notice that we have the proposition P, so that's true or false, and we have the negation. So we're going to include another column. Okay, which is the negation of P. Okay, and remember again in our discussion earlier that we're just going to have the reversed truth value of our proposition. If it is true, then its negation is false, and if it is false, the negation is true. Okay, then next one, as you can see here, we have the disjunction. Remember in our disjunction that at least one is true for that disjunction of the simple propositions to become true. So in this case, let's look at each row. So we have true and false. So obviously, at least one is true. We can say that this is true. And then for the second row, we have false and true. So at least one is true. We can say that this is true. So as you can see, P or negation of P is considered as tautology because the last column, all are true. Okay, all cases are true. While here in our contradiction, we use the conjunction. Okay, we use the inverted V. So obviously in our conjunction, if you will remember, both should be true. Right? Both should be true so that we can consider that as true. Okay, so take note of that. Okay, so as you can see, on each row, we have true, false. So obviously that's false. And then we have false, true. So that is false. So since both of the cases here are false, then we can consider this as false. Contradiction. Okay, this is a contradiction. Next, how about the contingency? Okay, contingency, it's the truth values for the conjunction, the disjunction, conditional and biconditional that we discussed in our introduction. So if you forgot that, try to rewatch. Try to rewatch our introduction. Okay, for the conditional, biconditional, conjunction, disjunction, and the negation. Okay, so it's significant. It's very important in our discussion in this video. Let's try to determine whether each of the following compound proposition is tautology, contradiction, or contingency. Let's have an example. If 8 is even, then 49 is a multiple of 7. And 8 is even, but 49 is not a multiple of 7. Okay, so let's try to symbolize this first. Okay, so for us to recognize the number of cases, the number of simple propositions, and the construction of the truth table. So in this case, we consider uh, simple propositions as 8 is even and 49 is a multiple of 7. So let's represent that as A and B. Let's represent that as A and B. Okay? So let's try to symbolize that. Okay, so the symbolized form of that is if 8 is even and 49 is a multiple of 7, so we use the conditional proposition if then. Okay, we have the if then. So we use one-headed arrow. Okay, then we regroup that. Again, remember if we're going to consider two or more simple propositions involved in our compound proposition and at the same time different connectives, we need to group them, okay, using parentheses. Okay, another one, we use the word and. Okay, so that's inverted V. And 8 is even, so that's A. But, so again, it's under conjunction, that is inverted V. 49 is not a multiple of 7. Okay, not. So that is negation of B. So therefore, this is now the uh, compound propositions in when we symbolize it. Okay. So recognizing this, as you we look at this, there are only two simple propositions. Okay, so since there are two simple propositions, that's 2 raised to 2, right? That's 2 raised to 2. And 2 raised to 2, that's 4. We have 4 cases here. So 4 rows. Now, what about the additional columns? So first, let's try to consider the negation. Okay, so look at the compound proposition. Is there a negation here? Yes, there is a negation, which is negation of B. So let's add that as the third column. The next one, try to identify the groups. Okay, so we have two groups here, and we have under it in inside the parentheses. Two propositions that is inside the parentheses, which are A then B, and we have A and negation of B. Then lastly, if we have the groupings, let's try to have now the overall, the compound proposition. Okay, our compound proposition. Okay, so as you can see here, we have 4 cases because we have two simple propositions. So that's 2 raised to 2, that's 4 cases. Okay, then we have the additional columns based on the given compound proposition. Okay, so now, let's try to identify the truth values on each column. Let's start first with the third column, with the negation of B. So remember, we're just going to reverse its truth value. So since we have here the column for B, let's just negate that. Okay, so all true will become false and all false will become true. So if we have here true, false, it will become false, true. Right? So all true will become false and all false will become true. So the true, false here will become false, true. Okay, so remember that. Okay? The next one, for the fourth column, we have A then negation of A then B. Okay, A then B. So we have A, one-headed arrow, B. Okay, so we have A as our premise. So this is the first column as our premise. So take note of this. Okay, this is our premise. Okay, and then our conclusion here is B. Right? Our conclusion here is B. Okay, so take note of that. And remember, if you will recall, when it comes to uh, the simple proposition, the compound proposition, which is under that is the conditional proposition, there is only one time that this will become false, right? When the premise is true and the conclusion is false. Right? When the premise is true and the conclusion is false. So look at the first column as our premise and our conclusion for second column. Okay, so look at this. The premise is true, the conclusion is true, therefore that is true. Right? That is true. Okay? And look at the second one. The premise is true and the conclusion is false. This is the only case that this will become false. Right? So this is false. Okay, this is false. The next one, the premise is false, the conclusion is true. That's true. The premise is false, the conclusion is false, that is still true. Okay, so remember again, in conditional proposition, it is only when the premise is true and the conclusion is false. Then it is false. Right? So this is false. Okay? Next one. For the fifth column, we have the conjunction of A and negation of B. Okay, we have the conjunction of A and negation of B. So look at the first column, okay, for A, and then another one, the negation of B. Okay, the negation of B. So look at the first and the third column. We're going to have its conjunction. And remember, when it comes to conjunction, both should be true so that the conjunction of the two simple proposition is true. Okay, so let's look at this. True, false. Again, look at the first and the third column only. So we have true, false, so that is false. We have true, true, so that is true. We have false, false, so that is false. And we have false, true, that is false. So only the second column. Because A is true and negation of B is true. So therefore that is true. Okay? Okay, for the last column for the overall of our compound propositions. So here we have the conjunction, right? We have the conjunction. So same procedure, but look at this. Okay, we're going to utilize the fourth column and the fifth column. Okay, we're going to utilize the fourth and the fifth column. Okay, just look at the fourth and the fifth column only. Okay, again, conjunction. Both should be true so that the conjunction of the two proposition is true. Okay, so we have true false, so obviously that's false. False true, that is false. True false, that is false. And false true false is also false. So as you can see, there are no cases that is both are true. Okay, so therefore this is all false. And all false is contradiction. Okay, we call this as contradiction. So the statement, if 8 is even, then 49 is a multiple of 7, and 8 is even but 49 is not a multiple of 7, is a contradiction. So all cases are false. Okay, all cases are false. Okay, so take note of that. Let's have another example. Okay, let's have another example. Here, we have P then, open bracket, Q, then one-headed arrow again, open parentheses, P and Q, close parentheses, close bracket. So as you can see here, it's group within a group. Okay, and we only have two simple propositions again. Since we only have two simple propositions here, then we can have 2 raised to 2, and that is 4. We only have 4 cases here. Okay, we only have 4 cases. Now, since it's a group within a group, what is our strategy here? Okay, so our strategy here is, let's start the inside. Let's start with inside, then we're going from inside to outside. Okay, so as you can see here, we start with the parentheses. Right? We start with parentheses. Okay, we have P and Q. So that is our additional column. So as you can see here, we don't have a negation. So that's why we proceed with the groups. We proceed with the groups. Okay, then the next one, inside the bracket, we have Q then P and Q. Okay, that's another column. Then lastly, we have the overall. We have the overall. Okay? So now let's fill out the third column, which is the conjunction of P and Q. Okay, so let's start with the conjunction of proposition P and proposition Q. So again, since this is conjunction, both should be true. Okay? So both should be true. Okay, so let's see. We have P and Q. So that is true, true. Okay, that's true. We have true, false, that's false. False, true, that's false. False, false, that is false. So again, both should be true. Okay, both should be true. Okay? Next one. Okay, next one. We have the fourth column wherein we have the conditional proposition. Okay, we have the conditional proposition. So take note, here we have our premise and our conclusion. So our premise here is the second column, okay, Q. And our conclusion here is P and Q, the third column. Okay, this is our conclusion. And our premise is the second column. Okay, so this is the premise and this is the conclusion. Okay, so again, remember when it comes to conditional proposition, there's only one case that this will become false when the premise is true and the conclusion is false. Okay, so let's look at this. So we have second and third column. True, true. So that's true. False, false. So that is true. True, false. That is false. Because the premise is true and the conclusion is false. So that is false. Then last one, we have the premise as true and the conclusion as false. So that is true. Okay? Last one. Okay, the last column. Overall. Look at this. Again, we have the conditional proposition. Okay, we have one-headed arrow. So as you can see here, we have the premise P. So we're going to use this first column as our premise. Okay? And our conclusion here is the fourth column. Okay? So take note, again, the fourth column here is our conclusion. So look at the first and the fourth column only. Okay? Look at the first and the fourth column only. Okay? So again, when the premise is true and the conclusion is false, that's the time that our conditional proposition is false. Okay? So look at the first and the fourth column only. So we have true, true, so that is true. We have true, true again, so that's true. We have false, false, that's true. Our premise is false and our conclusion is true, so that's true. Okay, so there's no case where our premise is true and the conclusion is false. So therefore, all cases are considered to be true. So if all cases are considered to be true, we call that as tautology. Okay, we call this as tautology. Okay? So again, our strategy, if we have group within a group, you start with the inside. Okay? Start inside. Okay? Last one. Okay, last example. Okay, so here we have P, then open close parentheses, Q or R. Okay, so as you can see here, we have proposition P, proposition Q, and proposition R. Okay, so since we have three simple propositions here, we have 2 raised to 3 cases, which is 2 times 2 times 2, that is 8 cases. Okay, we have 8 cases. So as you can see here, our first setup, okay, the first slide that I've presented to you earlier, this is the 3 columns. Okay, the first 3 columns. Okay, so take note of this. Okay? Now, here, we have conditional propositions. We have our premise and we have our conclusion. Okay, so here, let's start first with the group. Okay, let's start first with the group. So, since there's no negation here, we just skip it. And let's start with our conclusion, Q or R. Okay, so again, we have disjunction. Okay, we have the disjunction here. So, since we have the disjunction here, remember, okay, remember that we're going to consider the two simple propositions truth values. If at least one is true, we consider this as true. Okay, if at least one is true, we consider that as true. Okay, so let's look at each case here. So true, true. So that's true, true. That's true. True, false. That's true. False, true. That's true. False, false. That is false. Okay, so at least one should be true. Next one, we have true, true, so that's true. True, false, that's true. False, true, that's true. And false, false, that's false. Okay, so again, at least one should be true. Okay? Then, last one, for our last column here, we have our premise P. So, look at this. Okay, this is our premise. And our conclusion is this one, the fourth column. Okay, look at the first column as our premise and our fourth column as our conclusion. Okay, so this is conditional again. Okay, this is conditional. Okay, so take note of that. Okay, so now again, the time that the conditional proposition that is false when the premise is true and the conclusion is false. So let's look at this. Look at the first and the fourth column only. Okay, the first and the fourth column only. So we have true and true, so that's true. We have true premise, true conclusion, that's true. True premise, true conclusion again, that's true. True premise, false conclusion, so that is false. False premise, true conclusion, that's true. False premise, true conclusion, that's true. False premise, true conclusion, that's true. And false premise and false conclusion, that's still true. Okay? So there's only one case when the premise is true and the conclusion is false on our fourth row. Okay, so look at this. The last part, the compound proposition here, there are 7 truths and 1 false. So it's a combination of true and false. So therefore, we call this as contingency. Okay, we call this as contingency. Okay, so take note of that. Okay? Okay, so let's proceed to the last part. Okay, this is the last part of our discussion. Okay, so earlier we have an example wherein we have plural subject, right? We have the plural subject that we consider, but since it's too broad, we need to put keywords. Okay, we need to put keywords for us. Okay, to uh, determine, to identify that as a proposition. Okay, so that keywords is called as the quantifiers. Okay, it's a language element that helps in generation of quantification, which is a construct that mentions the number of specimens in the given domain of the scores satisfying a given open formula. Okay, so now, quantifiers can be classified into two. It's either universal and existential. So if we're going to discuss universal, universal quantifiers depicts the quantity of all or nothing, whole or none at all. Okay, existential quantifiers are in between. Okay, it's in between between the all or nothing. Okay? So what are the keywords to use when it comes to existential and universal quantifiers? So for existential quantifiers, we use some, most, there exists, at least one, someone, and somebody. For universal quantifiers, we use none, all, every, everyone, everybody. So as you can see here in universal quantifiers, we're going to use all or nothing in our population of our subject. While existential, it's in between. It's in between. Okay? So for instance, what are the examples of quantifiers? So we have here, all of you in this class are good in math. Number two, no smartphones are expensive. Number three, some students are not capable of having an online class. Number four, no airport is open. Number five, some movies are worth the price of admission. And then number six, most odd numbers are divisible by 2. Okay, so as you can see, let's try to determine the quantifiers used on each item. Okay, so we have number one, all. Number two, no. And then number four, no. It's universal quantifier. Then for number two, for number three, number five, and number six, some and most. Those are existential quantifiers. Okay, those are existential quantifiers. So now, our discussion for today is just an introduction to the quantifiers. Okay, it's just an introduction to the quantifiers. Okay, so now we're going to discuss only one part of it, which is the negation of the quantifiers. Okay, negation of statements with quantifiers. So our basis for the negation of the quantifiers here is the Aristotle's square of opposition. Okay, Aristotle's square of opposition. Okay, and also we're going to deal with the contradictories. Okay, there are lots of cases to consider when it comes to Aristotle's square of opposition, such as the contraries, subalterns, subcontraries. But again, we're going to focus on contradictories. Why? Because we are after with the complete, okay, opposite, or the opposite of the truth value of each statement. So that's why we're going to focus only on the contradictories of Aristotle's square of opposition. Okay, so we're going to deal with 4 cases. So what are the 4 cases here? So case number one, we have existential quantifier without the word not. So meaning the statement uses existential quantifier, but there's no not in this sentence. While case number two, it's existential quantifier having the word not. Case number three, we use the existential universal quantifier, which is negative. If we're going to refer to negative, that is no, none, no one. So no one is included in our population of our subject. Okay? And then we have universal quantifier non-negative, which means all are included. Okay, so all, every, everyone, everybody. Okay, so how do we negate this? Okay, so actually when you look at this, there are only two cases to deal with. Okay, but for you to understand each uh, possible case, we divided it into four. So what should we do when we are negating the statement with quantifiers? For case number one, existential quantifier without the word not, all we need to do is to replace the existential quantifier with a negative universal quantifier. For case number two, replace the existential quantifier with a non-negative universal quantifier and omit the word not. Okay, so given that you have existential quantifier and the word not, all you need to do is to replace it with the non-negative universal quantifier and you omit the word not. Okay, you omit the word not. For case number three, given that we have the universal quantifier, which is negative, so all we need to do is to replace it with any existential quantifier. Okay, replace it with any existential quantifier. And then for case number four, universal quantifier with non-negative, meaning all, every, everyone, everybody. All we need to do is to replace it with any existential quantifier, and we add the word not in the statement. Okay, so if we're going to look at this, case number one and case number three is just the opposite. Okay, so as you can see, replace the existential with the negative universal quantifier. And in case number three, negative universal quantifier, replace it with existential quantifier. While here, look at case number 2 and case number 4. So in case number 2 and case number 4, the existential quantifier, we replace it with a non-negative universal quantifier. While here, the non-negative universal quantifier will be replaced by any existential quantifier. In case number 2, we omit the word not. But here, in case number 4, we add the word not. Okay, we add the word not. Okay, so as you can see, it's just the opposite. Okay, it's just the opposite. So let's try to discuss case number 1 and case number 3, then followed by case number 2 and case number 4. Okay, so take note of this. You can screenshot this or you can check your module. You can check the presentation uploaded in your Canvas so that you have your guide whenever we negate. Whenever we negate the statements with quantifiers. Now, take note. Okay, there's no specific answer to a negation of statements. There are times that we have different answers. Answers may vary because, again, we can utilize different existential quantifiers or universal quantifiers as long as we follow the four cases here. Okay, so take note again, we are under contradictory. So make sure we follow the rules carefully. Okay, because if we're going to negate it and we don't follow the rules here, we can have the contrary, the subaltern, subcontraries of our statements. Okay, so again, we are under with the contradictories. And again, under the universal quantifiers for negative, that is no, none, no one. For non-negative, all, every, everyone, everybody. Okay? Let's have an example. For case number one, again, given that we have existential quantifier and we're just going to negate it using a negative universal quantifier. Okay, so for instance, some movies are worth the price of admission. So if we're going to negate that, so given that we have existential quantifier, all we need to do is to replace it with a negative universal quantifier. So no movie is worth the price of admission. Another example. Most odd numbers are divisible by 2. So if we're going to negate that, no odd number is divisible by 2. Okay, so as you can see, we have existential quantifier and we replace it with a negative universal quantifier. Okay, now, what about case number 3? Okay, let's jump to case number 3. In case number 3, this is the given. Okay, and our negation here is this one. Okay, so for instance, so again, all we need to do is to have that negative universal quantifier, and we will have any existential quantifier. For instance, no smartphone is expensive. So it's negation. So given a negative universal quantifier, most smartphones are expensive. So we replace it with any existential quantifier. You can replace it with many, with some, and so on. Another one. No one is above the law. So if we're going to negate that, some people are above the law. Okay, some people are above the law. Okay, so as you can see, negative universal quantifier, we replace it with any existential quantifier. You can use the word some, you can use the word most, many, and so on. Now, let's proceed with case number 2. With case number 2, we have existential quantifier with the word not. For instance, some students are not capable of having an online class. Some students are not capable of having an online class. So, in order to negate this, we replace some with any non-negative universal quantifier, and we're going to omit the word not. Okay? So, here's what will happen. All students are capable of having an online class. All students are capable of having an online class. So we replace it with a non-negative universal quantifier, and we omit the word not. Okay, so every student is capable of having an online class, so you can use the word every. Okay? Another example, many Filipinos do not prefer to have a luxury life. Many Filipinos do not prefer to have a luxury life, so we have existential, we're going to replace it with non-negative, and we're going to omit the word not. So we have here, every Filipino prefers to have a luxury life. Okay? Every Filipino prefers to have a luxury life. Okay? Now, what about case number 4? So in case number 4, the given is this one, and the answer is this one. Okay, so let's proceed. Okay, so case number 4, given that we have non-negative universal quantifier, all we need to do is to replace it with a existential quantifier rather, and we add the word not. Okay, we add the word not. Okay, so here's what will happen. Some in this class are not good in math. So we replace it with existential and we add the word not. Okay, so some in this class are not good in math. Last one, all dogs bark. Okay, all dogs bark. So if we're going to negate this, some dogs do not bark. Okay, some dogs do not bark. Now, in summary, for the negation, let's have this. Okay, so given that there's a statement, first you need to recognize if there's a quantifier used. Is there any quantifier used? If not, all you need to do is to just omit or add the word not. Okay? Just like what we did from the last uh, discussion, from the first part of our discussion. Okay? What if there's a quantifier? So the next question is it existential or universal? Is it existential or universal? If it is existential, the next question does it use the word not? Is there a not in your statement? If there's no not, case number 1. Okay? Case number 1. You replace it with a negative universal quantifier. But if there's not in your statement, you have case number 2. So all you need to do is to replace it with a non-negative universal quantifier and you omit the word not. What if we have universal? Okay, the next question here is it non-negative? If it is negative, you will use case number 3. So the negative universal quantifier, replace it with any existential quantifier. That's it. Okay? And then if it is non-negative universal quantifier, we can use case number 4. Okay, wherein we replace it with any existential quantifier and we add the word not. Okay, we add the word not. Okay, so take note of the four cases. Let's try to utilize that in our exercise here. Write the negation of the following statements. So start, you will pass this semester. You will pass this semester. So what is the negation of this? You can pause the video to think about the answer. Okay, so the negation of this is you will not pass this semester. You will not pass this semester. Why? There's no quantifier used here in our statement. So therefore, all you need to do is to just add the word not. Okay, so the negation of that is you will not pass this semester. Next one. Most of the students are in favor of online class. Most of the students are in favor of online class. Okay, so what's the answer here? It is under case number one because it has an existential quantifier. Okay, and there's no not in the statement. So all we need to do is to replace the most with negative universal quantifier. So we'll have none of the students is in favor of online class. Okay, none of the students is in favor of online class. Next one. Number three, everyone in this class is also taking up financial, accounting, and reporting. So this is case number four because it uses non-negative universal quantifier. Okay, so therefore, we'll replace everyone with any existential quantifier and we add the word not. So here's what will happen. Some in this class are not taking up financial, accounting, and reporting. Next one, number four. Most of the students have smartphones. Most of the students have smartphones. Okay, so this one again is under case number one. So we replace that most with a negative universal quantifier. So none of the students has smartphones. Okay, so none of the students has smartphones. Next one, number five. Human is the only mammal that farts. Human is the only mammal that farts. So here the negation of this is I spoiled it. Human is not the only mammal that farts. Human is not the only mammal that farts. So as you can see, human is singular and we don't have any existential quantifier. So therefore, all we need to do is to just add the word not. We add the word not. Last one. All perfect squares are even numbers. All perfect squares are even numbers. So to negate this is again under case number 4. All we need to do is to replace it with any existential quantifier and we add the word not. So the negation of that is most perfect squares are not even numbers. So we replace it with any existential quantifier and we add the word not. So most perfect squares are not even numbers. Okay, so actually here, the word not even, we can replace it with its other term, which is odd. Right? Not even is odd. You replace it with odd. Okay? So we can have the statement, most perfect squares are odd numbers. Are odd numbers. Okay?